Welcome to the Thermal Review, where we uncover the intricacies of thermal imaging technology. My name is David Bursell. In today's episode, we're diving into the role of input-output devices, or I/O devices, in creating multi-infrared camera monitoring solutions. From understanding the basics of I/O devices to exploring their seamless integration with thermal imaging cameras and delving into the history behind groundbreaking innovations like the Movitherm Mio. This episode promises to be a captivating journey into the heart of thermal imaging technology. So if you're ready to learn how I/O devices can revolutionize your thermal imaging experience, stick around as we explore the fascinating world of thermal monitoring solutions. Welcome to my co-host, Mr. Marcus Terran. Marcus, how are you today?
I'm great, Dave. How are you?
You know, I'm doing pretty good. I'm coming to you from New Hampshire, the state of New Hampshire, and Marcus is coming to you from our global headquarters in Irvine, California. And I'm going to go ahead and say it, Marcus. You're in our brand new offices there in Irvine, which, if anybody's in the area and wants to come see us, they're amazing. It's pretty amazing, the new digs.
Yeah, the new place turned out fantastic for sure. Yeah, I was long time in the making, but it's phenomenal. It's a great feeling to be here for sure.
Yeah. Oh, it is. We used to joke that we would call it Cardboard Canyon, because things would be stacking up in the hallway and in the
Yeah,
workspace areas, essentially shipping and receiving spilled into the office space.
yeah, definitely a lot more room here.
Yeah, for sure. Well, thank you, Marcus, for joining us today. Thank you for our audience. We're not here to talk about the new Movitherm offices. We are here to talk about I/O devices.
Right.
And we're going to try to gear the conversation today for both those who are just learning, but we also want to make sure that we're perhaps sharing information to those who are more experienced thermographers. So that's our goal and objective, is to make our audience dangerous, as I like to often joke, with information around I/O devices for thermal imaging. So to kick things off, Marcus, perhaps at a very basic level and maybe a little deeper, explain to our audience, what is an I/O device?
Yeah, it's a very simple but yet loaded question on some level, right?
Yeah.
So yeah, an input-output device, especially from the perspective of automation, is really the ability to sense something like a switch closure from the input side. And from the output side is also a switch closure. It could be a relay output or a solid state sort of an output to turn something on, right? And this could be an alarm siren. It could be an indicator light or any number of things that you would like to turn on based on a condition.
Okay.
And I guess we're talking here with respect to thermal imaging, right? But that's in a nutshell what an I/O device really is, right?
Okay. So yeah, maybe give us an example of where you would use an I/O device with a thermal imaging camera. You kind of touched on it, signaling an alarm, but maybe give us another example if you could.
Right. So there's different ways of applying thermal imaging, right? So let's say the maintenance technician is having a handheld camera looking at an electrical panel to see if something gets too warm. Well, that person typically does not have a need for an I/O device. They're just looking at a screen, they're measuring a temperature, and the input is the eyes and the human brain making a decision based on what they're reading, right? So
Yeah.
there's really no need for an I/O device. Um, but what we do primarily is fixed mount cameras that are monitoring autonomously 24/7. And if there's an alarm condition, there isn't a human sitting there looking at something, making a decision. There is the need for then notifying somebody and say, hey, your electrical panel, in the same instance, is getting too warm, right? So in an automated fashion, something needs to make a decision. So there's some logic there, and then the I/O device may turn on a relay that now turns an alarm on or a notification on. And in that sort of an instance, you need that capability, right? And cameras, some cameras come with a limited ability of having input outputs. Some have just outputs. The problem I see with that is always, well, okay, the problem is I have to maybe run hundreds of feet of cable because the output resides inside the camera enclosure or camera body. And I really want to have my alarm in my control room, and I may be hundreds or thousands of feet away. So it's not really that convenient to have an output directly on the camera, even though it comes as an I/O device. Certain cameras have that built in. But now I'm stuck with, okay, I have to run hundreds of feet of cables. That's not really that attractive now because it adds cost. And then by the time I have hundreds or thousands of feet of cable in between, I may degrade my signal to a level where I can't use it anymore. It's too weak now because because of the resistance of the cable. I cannot turn my relay on anymore. And also, in an industrial facility, I'm collecting a lot of noise along the way. So all in all, it's a nice afterthought from camera manufacturers, but most of the time it's not that useful to have it right on camera.
And I think you're kind of hitting on something here. These, I/O devices used in conjunction with thermal cameras, specifically, we're talking about fixed mounted automation cameras. It needs to be a certain type of automation camera. And our audience, some of you may be aware that it seems like these automation cameras come in two flavors, and you'll hear the terminology streamer or streaming camera, and then you'll hear the terminology smart camera. Marcus, maybe you can explain to our audience, well, maybe at a high level, what's the difference between streaming and smart, and then also what camera type works best with I/O devices?
Yeah, great question. So a streamer or a streaming camera, really, the jargon refers to pixel by pixel information being streamed over typically an Ethernet cable back to typically a PC that runs some software that receives these pixel by pixel information, and aka the image stream or the thermal video, if you will, and then reconstructs this on the screen for somebody to look at, right? Or for a software to process what's going on in the image, right? So that's really a streamer, or aka dumb camera, as opposed to being the smart camera. So there's no logic really running on the camera. All the logic is offloaded to a PC running some piece of software and making all of these decisions, right?
Okay.
Whereas the smart camera has the processing built inside the camera body, has all the decision making and everything. You can place regions of interest. You can say, hey, if the max temperature in this region gets too hot, give me that alarm and all those kind of things. So it's a smart sensor is often being used in the industry. Smart camera, smart sensor, and it's the same kind of concept applies here to thermal imaging as well.
Okay, gotcha. Now, of those two flavors, if you will, of cameras, where does the I/O device come into play? Which can you use an I/O device with both? Or is it just...
You can, with a little caveat, right? So if you have a streaming camera and you're bringing it back and you have that software piece that's now talking to the camera and making the decision, if that software piece now has the ability to talk on the other side, maybe also over Ethernet or some other interface, to an I/O device, then it can perform that same function, right? So that's a possibility. Okay. But you need to have a piece of software running on a PC that can also support an I/O device to get that functionality going.
So I need something in between, yeah. It sounds like. The I/O device and the camera. Okay.
Yeah. And the smart camera can typically directly talk to an I/O device without a PC and software in between, right? So you're saving yourself complexity. And you have a smart camera that can make decisions, right? So smart cameras are really good, or smart thermal cameras, therefore, are really good at simpler sort of applications where you can just say, look over here, if something gets too warm, then give me an alarm or something like this, right? Smart cameras are not so good for more complex tasks, right? Such as, certain applications where you have to make more complex decisions rather than just looking at an area and saying, is this hot or cold or something like this. if you have to track an object and then you have to make a decision. And so when it gets into that kind of a thing, then that's above what a smart camera is intended to do.
Okay.
Right?
Okay. Well, this actually leads me to my next question, because you and I were actually talking before the podcast, and we were talking about the role of a PLC. And for let's say for the very brand new thermographer, maybe you can describe what first of all, what is a PLC, but what role does it play in this whole automation scheme of things when it comes to camera, IO device, PLC, at a very basic level for folks, for me.
Yeah, I'll try to keep it simple.
Thanks, my good man.
So PLC stands for Programmable Logic Controller, right? So these are embedded computers that run an application-specific software that can be programmed, logic, right?
Okay.
That can make decisions. And a PLC is really an I/O device. It has inputs and it has outputs, and in between you have a piece of software running that makes decisions based on the state of the inputs to turn outputs on and off.
Okay.
So in the simplest form, and these PLCs are omnipresent. They're being used in pretty much any industrial automation sort of an application, machine controls and all those kind of things. And you can add a user interface or a HMI, human machine interface, to it to display some of this data or the logic or parts of the machines or whatever you would like. But it requires a PLC programmer to go in there and actually program that logic in, right? So some folks already have an existing PLC, and if they're now adding a thermal camera, let's say a smart thermal camera here, to the mix, they may have the ability to integrate that as an additional sensor, as an additional input device to the PLC now, and say, okay, if there's a temperature alarm on the camera, I'm going to be turning this relay on over there, or I'm going to turn my process off over here, whatever the case may be, right?
Okay.
So that's what PLCs are for.
And how might that PLC differ? I'm leading up to something. We mentioned this in the intro, and that is the Mio. We'll get to that. But very basic IO device, how would that differ from a PLC?
So there's simpler IO devices than a PLC.
Yeah.
Right. So there's certain IO devices that you can configure. I mean, if you have a timing relay that you say, hey, if you close this switch and then you wait 10 seconds and then the timing relay closes another thing or turns a relay on or whatever happens after, that is the most simplest IO device, right? So they have just a little delay timing circuit in between kind of a thing, right? So you can do simpler tasks with it, right? A PLC gives you the flexibility of changing the logic around. The origin of a PLC was really back in the days. All this logic was hardwired literally physically in a switching cabinet. So you had a bunch of relays and people were literally wiring these logical items and delay timers and everything physically in as physical components. And if something changed, they had to rewire physically things. So the idea was brought up to use a PLC to just in software change things and really just have sensory input and actuator output, and in between lives the software that you can now easily change around, right? So it saved a lot of components on one hand, and on the other hand, it saved a lot of time of not having to rewire everything if something changes, right? So that's kind of the origin of a PLC, really how that came to life.
Okay. Well, let's transition and talk a little bit about the Mio. And we've covered this in previous podcasts, the history of Movitherm. I mean, you've been in this for, well, actually, this year is the 25th anniversary, 25 years of being in business and running. So congratulations, Marcus, first of all.
Thank you.
And to the team at Movitherm. That's outstanding. But during that time, in solving problems utilizing imaging technologies through automation and monitoring type things or type scenarios, Movitherm, it developed an IO device.
Right.
and I was hoping you could share with the audience a little history behind that. Maybe why.
Yeah.
Why? I mean, were you bored? I mean, why? No. Why did you develop this? And then maybe bring us up to date on a very recent release that you made here at Movitherm. So could you do
Yeah,
that? Kind of
absolutely.
take us back in time and
Yeah, before I go in onto history lane here, when we released the Mio, a lot of people were actually confused about it. And then it took them a little bit to catch on and like, oh yeah, this makes actually a lot of sense, because we took um what we just talked about, the traditional realm of an I/O device. We took this and made it an application specific device that didn't exist before. So um and that became the Mio. Let me back off in history here. So it came out of a need of being a systems integrator, and every time we had to do a thermal imaging monitoring system, we had, again, in the beginning there weren't any smart cameras in the thermal field, so we had the streaming cameras that we mentioned before. We would write then the software based on the customer's needs, and we would plug in additional I/O devices as needed to turn relays on and off, right, to make these decisions automatically.
Mhm.
And every time, like the example I gave with the switching cabinet, every time you created something, the next customer had different needs, right? And we had to redo software, we had to redo our I/O devices and rewire the switching cabinet and do all those kind of things. And that got a little old after a while. And the customers didn't want to really pay for that extra labor that went in every time to modify a lot of things, right? So I looked at this stuff, and like I often do, and I'm like, there's got to be a better way to do this, right? And then we're like, well, the smart cameras came along around that time as well, and we're like, well, why don't we just use a PLC? But then I was like, okay, well, the PLC doesn't really have an HMI typically with it unless you put one on it. But then you're no better off. Then you're writing software for the PLC that you have to change. You have to have the knowledge of changing the software, so you can't. Most customers may not have that ability. And then you have to design a graphical user interface on a PC. How is that any different than writing software on a PC? It isn't really, right? And it doesn't solve the problem. We wanted something simpler. We wanted something more cost effective. Like, why do we have to reinvent the wheel, like with every application that we're doing all the time? Like, it wasn't scalable. It didn't really address the issue. And then I started thinking about it, and I said, well, what do we really need? Most monitoring applications need a camera or multiple cameras on one hand, and that problem was already there. I mean, it was already solved with the number of cameras available. And then you need some sort of a logic to make a decision, and then you need an I/O device that now gives you the ability to turn on an alarm.
Hmm.
And I'm like, okay. So then I sat down, I'm like, and light bulbs went off, and like, why don't we make it application specific? So I designed a little embedded controller that understands thermal cameras, and it can talk to the camera. So if you're creating a region of interest in the camera, I can read that in the Mio device, and you have a web-based graphical user interface. So all you need is a web browser to talk to the Mio. So there's no additional HMI or monitor or anything needed. You go in, type in the web address, the IP address of the device. The user interface comes up, and you can say, okay, camera 1. You just type in the IP address of the camera, and then you have a little pull down that says, okay, you have configured 3 regions of interest. Take the first one, say if this region's max temperature is higher than X, turn output 1 on. And I'm like, why can it be that simple? Why do I have to have a computer science background to do any of this? Like, it's got to be like a non-technical person should be able to just do this, right? So I challenged my team. Like, I mean, I designed this with a team, and I said it needs to be as simple as an app on your phone. It needs to be like somebody that's a non-programmer needs to be able to hook up multiple cameras in within a few minutes, is monitoring, and the whole system is done. And I got a lot of blank stares when I said that as a challenge, and I said that's how good it needs to be. And then we went to work at it, and we actually managed to do that, right? So now we have the Mio that we released several years ago, and it can literally do this. You can literally talk to one or many cameras, and with 2 or 3 mouse clicks, you're up and running, and you have a complete monitoring system. No software to develop. You don't even need a systems integrator if you know a few things to wire a couple of things up. You can put this thing in your switching cabinet. It sits on the network, and you're off and running. And it's beautiful. It has reduced the cost. It has reduced the complexity. It's kind of like pretty much a self-install situation. You don't have to fly an engineer out to install. So we solved a lot of tough challenges with that little box, right?
Yeah. And well, one of the challenges you described earlier, and it's great that some cameras, smart cameras, have I/O capabilities built on them. But like you were saying, if the switch or relay is 1,000 feet away, you're running cable forever just to get to that point. Describe how you solved that with Mio. I know how you solved it. Tell our listeners how you solved that with Mio.
Yeah, so since most of these cameras are kind of like IP cameras or like surveillance cameras in a sense, so that they are using Ethernet communication, and the customer typically has an existing infrastructure, we said, well, this I/O device should also be capable of existing on that same network, right? So it's actually a networkable device with an Ethernet port on it, so you can just plug it into the same network as the cameras are operating on, and they can talk to each other. And you can cascade things. If the larger Mio can support up to 7 cameras. If you have more than 7 cameras, you can just simply plug in a second one and a third one and a fourth one. You can scale it up as to 1,000 cameras if you want to. It's not a problem. And then you can place the device where you actually need to switch something. So it could be in your control room because you want a light to come on or something like this, right? So you can place that anywhere on the network, and it gives you the flexibility to move this thing around anywhere you want, and you actually get the output where you need it, and you don't have it somewhere in your outdoor facility where it's like, okay, that's great, that's the camera out there, but I really want to do something over here if the camera tells me to do something, right?
Yeah, I have to admit, I didn't really appreciate that what seems to be a very basic and simple feature of the Mio initially as much as I do now, which is it simplifies things dramatically. I was under the impression, I think a lot of folks are, that the cameras connect directly to the Mio device, so they have to be not line of sight but cabled directly to it. But that as you just described, it's not the case. They just have to be on the same network. They can be
Right.
anywhere. They just have
Right.
to be on the same network. So Mio can be not even close to where the cameras are, and the cameras can be just as far away. But as long as they're on the same network, which it creates so much flexibility
Right.
in whatever monitoring solution or problem you're trying to solve, which is wonderful. And just so our audience is aware, the Mio, it comes in different flavors. You mentioned the one that 7 cameras, which is great. You need more, you can add to that. But you also have one for just a single camera, if I'm not mistaken.
Right.
A simple I/O device. You one camera, one I/O device. Put that anywhere you want.
Yeah. It has limited output capabilities. It has 2 digital outs that are 24 volts industrially rated. They're also protected, like proper standard industrial equipment should be. In addition to the digital outs, they're basically just on off. You can also tap into 2 analog outputs, which are 4 to 20 milliamps, right? So that allows you to scale the temperature that the camera is reading in real time and output them as 4 to 20 milliamp current loop. And that's a very typical interface used still today in industrial environments. And it's current driven, so it allows you to run, again, thousands of feet of cable if you need to, but this time without major losses, because the circuit inside adjusts for the resistance for the losses in the cable and keeps that within reason, but it keeps that the same. And it's used in a lot of process control applications, for sensors and actuators.
So two digital IOs on the Mio 1
Hmm.
that supports a single camera. How many IO outputs off of the I think it's the Mio 7 that
Yeah,
supports
that
7
one has
cameras?
that one has 8 outputs, 8 digital
8
outs,
outputs.
and 8 4 to 20 milliamp current loops.
Wow, all in one device.
Yeah, and you can
That's
mix and
amazing.
mingle them. You can say, I need one digital for this, I need two for this camera, I need, mix and match them. You can do this in any which way you want.
Okay. Now, um, I mentioned previously that Movitherm just made a major announcement. I think just a couple of weeks ago, maybe even just last week, about the Mio, a next generation. Um, tell us about that, Marcus.
Yeah. So it again, it's our thriving, or us thriving for making things easier and simpler, right? So when we first released the Mio, it was a camera specific device. So there was a particular FLIR camera, let's say the FLIR AX8, and it had the Mio AX8 paired up as the designated IO device, right? And the FLIR A310 had the Mio A310. So it was always camera specific. Now we were able to, based on customer feedback, like they were telling us, well, why can't we not just buy one Mio, like the buy one fits all argument?
Hmm.
And we have now improved it so that we actually do have that device, and that is our Mio Max. That is now compatible with all new FLIR A series cameras in the smart configuration, not the streamers, because on the streaming side it doesn't make sense.
Yeah.
So it's the smart camera. So it's the FLIR A50, A70, A400, 500, and 700, and the AX8 essentially. So you can choose from all of these flavors and hook them all up to the same Mio Max box, whether it's the smaller one that supports one camera or the larger one that supports up to 7. But you can even mix and mingle. You can say, I have two AX8s and two A50 Smarts. You can put them on the same Mio now. And it's all the same box. And it's also, we were able with all of that to reduce the price of that Mio box even further to make it even more attractive.
Brilliant. That's wonderful, Marcus. So I love that ability to mix and match.
Yeah.
So if there's a listener out there currently that has a collection of FLIR cameras, AX8, A50, A70, 400, 500, 700s, and needs to mix and match to create a monitoring solution, Mio Max sounds
Right.
like your solution to easily do that.
Right.
Yeah, excellent. Well, congratulations on that release, on that
Thanks.
launch. I know there's I don't want to say a ton, but a lot of information out there on Mio, training content and supporting documentation. Somebody wants to learn about the Mio IO device. Where should they go, Marcus?
Yeah. I mean, right on our website at movitherm.com. And then there's a knowledge base section. We have a lot of content in there. We will keep adding more content to it. There's also obviously the product section that describes in detail what the Mio is and the Mio Max specifically. We have some more videos coming out. And of course, you can call us at any moment if you guys have any sort of questions, whether it does something or it doesn't do something, by any means, just give us a call. We'd be more than happy to explain it. And yeah, and we have plenty of these on the shelf now, even, which is fantastic, because we did have, after the whole COVID mess, we did have supply chain issues that really it caused some grief there, because there are certain computer chips that were just not available, and they were so backlogged that we just couldn't get them. And now we made a big batch, and we bought some extra of those chips just to make sure we have plenty of extra around.
Excellent. Yeah, and if you want to, I've even seen most recently. I think it was Michael at Movitherm who did a demonstration for us of the Mio. There, he has a demo box, and took us through and educated a team on the capability. So if you want to see one in operation and see how it works, reach out to the Movi team as well, and they can help answer any questions and show you how the device works. this kind of wraps up our podcast for today, but it's not going to end just here. There's other devices out there that can be utilized to connect thermal imaging cameras, infrared cameras. And you may have heard the terminology like gateways, intelligent gateways. And this is something that we want to address and help you, our audience, understand the difference between an input-output device like the Mio versus a gateway device. What's the difference? When would you use one over the other? So in our next episode of the Thermal Review, that's what we're going to be diving into. We'll be diving into a little more of what intelligent gateways are, the different kinds that are available, and how they differ from input-output devices like the Mio. And that's all in the spirit, again, of making our audience dangerous. So, Marcus, any parting comments to our audience before we wrap up today?
Yeah, I'm just again super excited that we have the Mio. The Mio's back, and in a much more powerful sort of a way. And I'm excited. Hopefully people appreciate out there how easy that makes their life, and hopefully helps them save some money on their monitoring solutions. And I can't wait to learn more about what folks are doing out there. We rarely get a lot of insights. I mean, people are buying this stuff, and we have some conversations sometimes, but for the most part, which I guess speaks to the reliability of that product, but we rarely get feedback in terms of what are you guys doing? Like, let us know. Let us know what you guys are doing, what kind of problems you're solving with this stuff. Maybe we can invite you to a podcast and you can tell a story of how you used Mio and how it has helped solve your problems. That would be fantastic.
That's a brilliant idea. I love that idea. And I think you're right. I mean, yeah, we'd like to hear more feedback and response, but sounds like Mios are running perfectly, and they're running worldwide.
Right.
They're all over in operation. Well, thank you again, Marcus. As we conclude this episode of the Thermal Review, we hope that you've gained our audience valuable insights into the pivotal role of input-output or I/O devices in regards to thermal imaging technology. And whether you're a seasoned professional or a curious enthusiast, we always encourage you to continue exploring the possibilities unlocked by these amazing and innovative devices. Please don't forget to subscribe for more captivating discussions on thermal imaging technology, thermography. And as always, feel free to reach out with any questions or topics you'd like us to cover in future episodes. And until next time, stay curious, stay informed, and keep pushing the boundaries of thermal imaging technology. Thank you.
Thank you.